Assalamu alaikum. My name is Moaz Ahmed and in this video I will be explaining the lab number 10 of microcontroller and embedded systems. In this lab, the main purpose is to introduce and implement fast and phase correct PWM using Atmega 328P to control DC motor speed. So, PWM, what is PWM and how can we implement it is the main objectives of this lab. For this lab, we have to perform two different tasks. First task is to use PWM to control a LED, and the second task is to use PWM to control the speed of a DC motor. So if I move here, we can see here that modes of operation of PWM of timer counter 0 module are normal mode, CTC mode, fast PWM mode, and phase correct PWM mode. We have discussed these modes very much in detail in our course and in our previous labs. So I will just skip ahead to the main two tasks of this lab. So we have our task right here. So if I open my Proteus file right here, this is the task one. And we can see here that first of all, we have included the input output libraries. Then we have defined the frequency. Then we have added the delay library. And in the main function, we first of all declared the PB6 as output. And then TCC R0A register is being used and COM0A1 port is turned on and WGM00 is also on, which means if we go back to our circuit, we can see that WGM0100 being on means it is phase correct PWM. It is phase correct PWM, and our second case is COM0A. So here we can see that COM0A in fast PWM, in phase correct PWM, COM0A in sorry COM0A1. In COM0A1, if COM0A1 is 1 in phase correct PWM, it means that we are to clear OC0 on compare match when up counting, set OC0 on compare match when down counting. So if I go back to my circuit, we can see that TCC R0A is being set, and then TCC R0B is simply storing a value of 0x01, which means we are using no prescaler in our task. And then in the forever loop, we have set OCR08 to a value of 0, and then we want it to do something while a certain condition is true. We want it to delay for 500 milliseconds, like half a second, and we want it to increment the value of OCR0A, which was initially 0, by 40. And we want it to do this process as long as OCR0A is less than 200. And after that, we want it to implement same code again and again as it is being placed in the while one loop. PWM basically means giving an analog value to an object like The main function of a DC motor is to rotate, and if we send a specific analog value, then it means that only that much voltage is being supplied to the motor at that time, and thus the speed of that motor will be set accordingly. In a simple LED's case, instead of speed, we are controlling the contrast of the LED. As you can see, when I will run this program, this is the task one. Look here, you will notice something. You can see that it is slightly brightening up each time, and then it goes back to zero. Same is thing is happening right here. So this is the task one of our PWM tasks, PWM lab. And for the task two, our code is right here. In the task two, it is pretty much the same, but here we can see that it has turned on the 8th bit, 7th bit of port B as output, and then we are using TIMS function, EIMSK register, and in it we are enabling different interrupts. And TCCR0A has the same value. TCCR0B is still no prescaler's case, and then we are calling the SCI function, which means set enable interrupt. So then we are calling the while one loop, and in it we are calling OCR0E is equal to duty cycle. Like whichever interrupt will be called, we want it to whichever interrupt will be called, we want it to act accordingly, according to that duty cycle that will be provided by that specific interrupt. And in different ISRs, interrupt service providers, we can see that in different interrupts, it is setting the duty cycle accordingly. So if I go back to my Proteus file right here, so in the Proteus file right here, we can see that if I zoom in a little bit, so if I run the file, we can see that if I press this interrupt right here, we can see that the motor is slowly rotating, which means the duty cycle is the minimum of all here. And if I press the second interrupt, it is a little bit faster, more faster, more faster, and now it is at the 250 duty cycles. So that's it from the left hand, and I hope you learned something valuable. Till next time, Allah Hafiz.